All right, in this video, I just want to talk about how to split up that weight or force of gravity force into its components, all right? So whenever you see something on an inclined plane, okay, it usually has like a picture, right? I would start by drawing the force diagram right on the picture, okay? Right, so from the center would be your FG, okay? And then usually we kind of just put the forces on the force diagram as coming from the center, but sometimes in AP, they want you to draw it like where it acts, they'll say, right? So if they give you like a box, right? The normal force would actually come from the ground or the ramp, right? Perpendicular to it. So that would kind of go there. And then if there were a friction force, right, you'd kind of show it here, okay? So it just depends on what the question asks. Sometimes they'll give you a dot and ask you to draw on it, and sometimes they'll actually show the box or the whatever, and then you'll have to, like, you know, have the forces, you know, like that, okay? All right, so usually in an inclined plane problem, there's always going to be weight or a force of gravity. Oftentimes there's friction, but sometimes not, like it'll say an icy slope or something. And then there's some kind of normal force from the ramp, some kind of perpendicular force, like those little springs in the ramp kind of being crushed down and popped back open, okay? All right, so the thing that you want to do when you do an inclined plane analysis is the first thing I would do is I would draw, okay, the force diagram exactly like you see it on the picture, okay? Right, so I would just kind of do it right from here, and I would just put everything from that middle dot, right, at this point, okay, FG or weight, okay? All right, you could do a traditional XY, but that's going to be a hassle, so we usually, like, twist the axis this way, okay, kind of into an X and Y. Sometimes you'll see it parallel, perpendicular to the surface, okay? So here's the key for inclined plane problems. Redraw that, right, the correct way that it shows, okay? So redraw it, oops, that's not even right. Okay, so redraw it just basically like if you twisted your head, okay? So your FF will be this way, my FN is on the Y, and then in this one, my FG is kind of off to the side right here, okay? So all you're doing basically is like tilting your head, all right? Now, here's the other tricky thing about the inclined plane problem. There's some geometry reason why, and I don't really ever care, but this angle here, okay, is always this same angle between the FG and the Y axis, this one right here, okay? So as long as you know that, you're good. They're not going to ask you to prove that, I don't think. But whatever the ramp angle is the same as the FG to the Y axis, all right? Okay, so then if I kind of redraw this now as on the axes, okay, now I'm going to have this FGY and this way FGX, right? Because I'm going to split this guy into the components, okay? All right, and when I look at this triangle, right, that's my theta, that's my FG, that's my FGY, that's my FGX, okay? And like we talked about a couple videos ago, right? Oh, shoot. All right, this angle you have to be careful because see now the theta is across from the x, so that's going to be a sine. So you're going to have FGX is FG sine theta, or we could say MG sine theta. And then FGY is MG cosine theta. All right, so when you split those, right, that's the components you're going to use, and they become these. And then you just solve it like a regular problem. All right, so the only, not tricky thing, but the only thing to remember is that angle, ramp angle, is the same as the angle between the y-axis and the FG when you redraw it.